It is a great honor and privilege to present my paper at this summer session. I would like to extend my sincere gratitude to the organizers, reviewers, and the technical committee for providing a wonderful platform to share research and exchange innovative ideas. My name is Nagireddy Vasipally. I have 18 years of experience in enterprise integration, and today I am pleased to present my paper titled Enterprise Integration with Oracle SOA Microservices and Organizations Continue Their Digital Transformation Journey. Enterprise integration has become increasingly complex. Legacy enterprise systems must seamlessly communicate with cloud native while maintaining security, scalability, and high availability. This paper explores how Oracle SOA microservices architecture and cloud technologies can work together to create a modern, resilient, and efficient enterprise integration framework. Let's begin. The modernization imperative. Modern enterprises must transform their legacy IT into agile, cloud-enabled ecosystems without disrupting mission-critical operations. Oracle SOA Suite cloud-native microservices, event-driven architectures, and API management collectively provide the foundation for the transformation. The goal is modernize incrementally, not all at once. The integration challenge. Fragmented enterprise landscapes spanning ERP, CRM, financial systems, and custom apps create hidden bottlenecks, brittle dependencies, and mounting operational risks that compound with every new integration. Some are protocol mismatch. Incompatible standards like SOAP versus REST and XML versus JSON force costly translation layers, slowing delivery and introducing error-prone workarounds at every boundary. Tight coupling. Point-to-point integrations multiply into an unmanageable web. A single system change cascades into widespread failures, making the architecture increasingly brittle at scale. Compliance and security. Distributed hybrid environments multiply the attack surface, enforcing consistent authorization policies, audit trails, and regulatory controls across disparate systems is exponentially harder. Oracle SOA, the integration backbone. Oracle SOA Suite exposes reusable business services while abstracting implementation details from consumers, reducing dependencies and simplifying maintenance. Oracle Service Bus for routing, protocol conversion, and transformation. With the help of people, we do develop long-running workflows and exception handlings. Rule engines help to update business logic independently. With the help of adapters, we do connect ERP systems, databases, cloud, and JMS servers. Microservices modernization strategy. Rather than rebuilding entire applications, organizations gradually extract business capabilities into independently deployable services like customer profile services, order and inventory services, payment services, notification services. Spring Boot simplifies development. Container platforms automate deployments, scaling, and service discovery. Spring Boot and containers. Why Spring Boot? Spring Boot has become the preferred framework for enterprise microservices, simplifying dependency management and configuration, REST implementation and security integration, testing and containerized development and deployment. Container benefits: automated deployment, scaling, health monitoring, and service discovery, minimizing disruption while enabling continuous delivery. Event-driven integration with Apache Kafka. Not every enterprise interaction should rely on synchronous APIs. Apache Kafka enables high throughput asynchronous messaging where producers and consumers operate independently. By decoupling services through durable, distributed event logs, Kafka enhances system resilience, allowing individual components to fail or scale without cascading disruption across the integration fabric. In enterprise architectures, Kafka serves as a real-time streaming backbone connecting microservices. Legacy Oracle SOA composites and downstream analytics platforms via Kafka connect bridges and MQ-compatible messaging adapters. Kafka key advantages. Applications publish business event at once. Interested services subscribe independently. No direct coupling required. Typically, enterprise events: customers created, invoice generated, payment completed, shipment dispatched, inventory updated. Oracle SOA consumes Kafka events via adapters or messaging bridges, combining process orchestration with event-driven scalability. REST and SOAP interoperability. Why this matter? Enterprise environments rarely standardize on a single protocol. Older systems expose SOAP or XML. Cloud-native platforms prefer REST or JSON. Protocol mediation allows backend modernization without forcing changes to existing client applications. Oracle Service Bus mediates between legacy SOAP services and modern REST APIs, protecting existing investments while enabling gradual modernization. API governance and security. As enterprise services multiply, governance becomes essential to prevent inconsistent design, duplicate services, and security vulnerability. A centralized API gateway enforces consistent policies, including rate limiting, authentication, and versioning across all services, providing a single enforcement point that eliminates fragmented security configurations and reduces the attack surface. Structured API lifecycle management, spanning design, publication, versioning, and deprecation, minimizes technical debt and ensures backward compatibility, allowing service consumers to rely on stable contracts even as underlying implementation evolves. Governance and OAuth security framework. Governance standards covers design like naming convention, documentation, lifecycle management like onboarding, rate limiting and retirement, security like authentication, authorization, monitoring. OAuth plus API gateway controls, token-based delegated access, transport layer security and mutual certificate authentication, input validation and schema verification, threat detection, audit logging, data masking, token expiration and centralized enforcement, workflow automation with Oracle BPEL. Complex business operations span multiple systems. Oracle BPEL orchestrates distributed workflows end-to-end. Bipil coordinates service invocation, manages transactions, handles exceptions, performs retries, and records process history, reducing manual intervention and improving consistency. Automation beyond onboarding. Workflow automation enables organizations to implement approval chains with configurable escalation rules, service level monitoring across process steps, business process visibility for operational teams. Automation improves consistency while freeing teams from repetitive manual coordination. Resilience by design. Circuit breakers prevent cascading failures when downstream services fail. Retry and timeout. Recover from transient failures, prevent blocked transactions. Message queues. Isolate disruptions, dead letter queues, preserve failed messages. Health checks. Continuously verify service availability, observability and operational excellence. Comprehensive observability, centralized logging and distributed tracing, performance dashboards and business transaction monitoring, alerting systems and capacity analytics. Operational metrics enable teams to detect anomalies before users experience disruption and support capacity planning and performance optimization. Cloud deployment architecture. Cloud platforms provide infrastructure elasticity while reducing operational overhead. Enterprise integration workloads deploy via Kubernetes orchestrated containers. Managed cloud integration services, hybrid and multi-cloud connectivity, infrastructure as code for consistent provisioning. Oracle Cloud Infrastructure, Kubernetes, and managed API gateways provide enterprise-ready hosting environments. Implementation lessons learned. Avoid Big Bang replacement. Incremental migration reduces risk and allows validation at each phase. Build for reuse. Reusable enterprise services deliver greater long-term value than project-specific integrations. Govern early. Establish API governance before large-scale adoption begins. Automated everything. Testing, deployment, monitoring, and security validation throughout the lifecycle. Future directions. Enterprise integration continues evolving alongside AI, cloud, and automation advances. AI-assisted orchestration, intelligent workflow automation, API discovery, self-healing platforms, predictive monitoring, automated anomaly detection, low-code and agentic, semantic transformation, autonomous testing, agentic orchestration. The complete architecture. Combining Oracle SOA with Spring Boot, microservices, Kafka, API governance, workflow automation, and OAuth security creates a flexible architecture supporting both current operations and future growth. Conclusion. Enterprise integration is not a technical project, it is your competitive advantage. The organizations that win are those that treat legacy systems as launchpads, not liabilities, and turn integration into a strategic engine for growth. Modernize incrementally, protect what works, unlock what's next, evolve at the pace your business demands. Governance and secure. Security and governance aren't afterthoughts, they are the foundation every great architecture is built on. Monitor and adapt. Systems that observe themselves, heal themselves, and evolve continuously. That's how transformation becomes permanent. Thank you for giving me this opportunity to present my paper at this summer session. I would like to appreciate yours and organizers for this wonderful opportunity. Thank you for joining me today. Thank you very much.